Hello everyone. Okay, I hope you're all doing good. You're doing fine. Our next topic is centroids and centers of gravity. Okay, so this is a review of, integral calculus. This is one of the applications of integral calculus where you solve for the center of gravity of a certain area, line, or curve, ano ba ba? Solid figures. Okay, so this is one of the applications of integral calculus. So if you have already discussed that integral calculus, which I think you have, no, you had discussed this before in integral calculus. So again, we are going to discuss it again here in this subject. We're going to focus more on the centroid or center of gravity of composite areas or composite figures. Okay, so it's just a brief review of the concepts. Don't worry, we will not be integrating dito sa ating sa topic na ito. Although kung you can always apply the principle of integral calculus in solving for the centroid, but in this topic, since napag-aralan na natin sa integral calculus yung pag-solve ng centroid ng areas, so meron na tayong derived na formula to solve for the centroid of a certain regular figure or area. And then we will just going to use those derived formulas in solving for the centroids of composite areas. Okay. So ano bang principle, other concepts? Mga concepts natin. So definition of terms. Center of mass. It is used to denote the point in a system of particles of physical body where the mass can be conceived to be concentrated. So yung center of mass, usually yun din yung centroid or center of gravity. No? So center of gravity, the point in the body through which the weight acts. Okay, centroid. So yun yung center of gravity. Okay. So centroid of areas. Centroid of areas. Actually, we had, I think, discussed this before dun sa previous topic natin sa pag-solve ng resultant ng uniformly varying loads or uniformly distributed loads, no. For example, we have a beam, simply supported beam, so meron tayong uniformly distributed load, which means na rectangular yung loading natin. So uniformly distributed load. So the resultant of this uniformly distributed load is just the area of this one of the loading. It's length times the intensity of the loading, and the location of the resultant. The resultant is at the centroid of this area. So it's a rectangle. So obviously, pag rectangle, so the resultant is located dito sa L/2 since sa center line natin symmetrical naman. So very obvious for rectangular areas, the resultant is at L/2 or H/2, ano. Okay? So for rectangular areas, this is base and this is the height. So the center here is always located, that's H/2. The center is B/2, no, from this axis. B/2 from this axis and this. And this center is H/2 from relative to this axis or from the bottom. Okay, so ganun yung center. For rectangular naman, for triangular shapes, so for triangles, just a review of what we have discussed before in solving for the resultant of uniformly distributed and uniformly varying loads. For triangles naman, ang center niyan, if this is the base, ano, and this is the height, this is b over 3 from this axis. Okay? Which means that if you are going now to solve for the center of this triangle relative to this point, no, dito sa dulo, this is 2/3 of 3, no? 2/3 of 3. 2/3 of the base, no? 2/3 of the base ito. So 2/3 of b ito. So from this axis, that's b over 3. From this point, this is 2/3 of b. And the center from this axis is h over 3. No? Which means that if you're going to solve for the center of this triangle relative to this point dito, sa may dulo ng triangle, that is 2/3 of h. Okay, so saan galing mga formulang yan? We have derived that using integral calculus. No, integral calculus. So sa integral calculus, just a brief review of what we have. Kasi ito yung formula natin eh. What we have done before sa integral calculus. If you want to solve for the centroid of a certain plane area here. So solve mo yung centroid niya. So this is x-axis, y-axis. This would be the center of gravity or centroid, no, of this area which we want to solve the center. So dito siya somewhere here. So take note that we always solve for the centroid relative to a certain axis or certain point. No, so meron tayong baseline axis or datum. I don't know how to pronounce it. May baseline axis tayo. So we usually solve the centroid relative to the axis dito, x-axis. So we call this, and the y-axis. So x-axis from the x-axis. And from the y-axis, eto. So we call this y-bar because that's the y component of the centroid. So yung component ng y coordinate, I should say, component. So this is actually, that is y bar, that's the y coordinate of the centroid. Okay, that's y bar. Other books, I don't know the notation of their centroid, but usually most books naman sa statics, even sa integral calculus, we call this y bar, the y coordinate of the centroid. And this is the x bar, that's the x coordinate of the centroid. So yung coordinate niyan is x bar, y bar. So that's how we solve for the, that's how we locate for the centroid, no. So kunin natin yung x coordinate ng centroid and then the y coordinate of a centroid. So it's always based on a certain axis. So sometimes hindi naman ganito yung baseline natin, depende sa situation or sa problem. Okay, so yan. So how do you solve for the centroid? Again, we are actually going to use the principle of moments. No, we're going to use this principle of moments. So to solve for y bar here, just a review, I know you already know this from integral calculus. To solve for the y bar, ito, yung location ng centroid relative to the x-axis. Ayan, that's the y coordinate of the centroid. To solve for the y bar, so using the principle of moments, using the principle of moments, yung moment ng total area, okay, relative to x-axis, no, yung moment niya dyan, should be equal to the moment of the differential areas here. So we're going to divide the area. Kapag irregular yung area natin, we are going to divide the area into differential areas. So differential strips. So yung may area yan, okay, divide natin yan into differential strips. So this can be considered as a rectangle or triangle. So depende na kung ano. So differential strips, so basically ito yung area natin, that is DA. Sabihin natin DA. Differential area, kaya DA ano. So yung moment ng total area relative to x-axis. So ito, yung moment arm niya, of course, yung dun sa centroid times yung y bar. So yun yung moment arm niya, y bar. So yung moment ng total area, total na yan, yung total area natin. Is it recording? Yeah. Times y bar, okay, it should be equal to the moment of each differential strip relative to x-axis. Okay? So the moment of each differential strip relative to x-axis. Okay, so if this is dA, na magsimula tayo sa baba papataas, ipunin natin yan. It is the concept of integral calculus, ano? We summate all differential strips there. So, dA times ito yung y natin. Distance, centroid nito, differential strip, papunta dun, moment niya papunta dun sa may, moment niya about the x-axis. So, lahat ng strips na yan, may moment. So, ipunin natin yan. So, that is y times dA. Okay? So, ipunin natin lahat ng differential strips, the concept of integral calculus. So, that's basically the concept we're going to use here in this topic. We're going to use the principle of moments to solve for the centroid of composite areas. Okay? So, the principle is yung yung moment ng total area is equal to the moment of each individual areas. In this case, the differential areas. No. Ayan. Sum of the moments of each differential areas. Relative, of course, to the x-axis if you want to solve for the y-bar. So you can solve for the total area, and you can solve for this one with, of course, yung limits natin. So, depende kung horizontal or vertical strips ang ginamit natin for solving. But I've said, as what I've said a while ago, we're not going to use integral calculus, but you can use it. No, I'm not hindering you to use integral calculus to solve for the centroids later on of composite areas. Okay, but it's just I've discussed this to illustrate lang yung principle that what we are going to use later on sa pag-solve ng centroids. Now, using this principle, the same din dito sa may sa may x bar. If you want to solve for the x coordinate of the centroid, again, mag-moment lang tayo about y-axis naman. Okay? About y-axis. So, ang unknown dyan later on is the value of y bar and value of x bar. Okay? And then you will be able to solve for the y and x coordinates of the centroid. Okay? So, ito pala sa module natin. So, ito yan. That's the formula na ginagamit. If you can still remember this, ito yung formula na ginamit ninyo before sa pag-solve ng centroid ng areas, plane areas, ano pa yung ibang ng calculus? Yeah, yung length ng line length ng line, ano pa ba yung kwan? Mga application, maraming applications ang integral calculus, no? So one of the applications is yung pag-solve ng centroids and centers of gravity. Okay? So, ganon. Okay, for now, the application of this concept, yung pag-solve ng centroid, ay baka hindi nyo pa masyadong ma-appreciate, but this is very important later on sa design subjects ninyo. Okay, even for your next major subjects such as hydraulics 1 and strength of materials or mechanics of deformable bodies, you're going sa may latter part nun ng mga subjects ninyo, you're going not to use this principle or concept of centroid, and pati yung next chapter, which is the moments of inertia. So moment of inertia of areas. Okay, so these concepts are very helpful, no? Ito yung gagamitin natin sa pag-solve ng stresses, pag-solve ng stresses, bending stresses na experienced by bodies or structural elements which are subjected to loadings, different types of loadings. Okay, so for now, dapat ma-master natin na mag-solve ng centroid, center of gravity, and then moment of inertia of shapes. You're going to apply this sa next na subjects na ninyo. Okay? So, basta i-master muna natin dito sa subject natin, sa course natin, kung paano mag-solve ng centroids and moments of inertia. Okay? So, it's the principle we're going to use sa pag-solve ng centroids. Okay? So ito na yung derived formulas ng mga centroids natin. Centroids for regular shapes such as triangular area. Yung triangle natin, ito. So yung center niya, sabi ko kanina, is h over 3. So in this triangular area, so na-bisect siya dito. So obviously, yung center niya from this axis, yung y bar natin, ay yung dito sa may x bar. If you're going itong nahati siya dito, anong tawag dito? I already forgot. Basta ito. Yung location ng centroid niya dito. Ayan. Dito siya sa gitna ng... gitna tuloy. Yung centroid niya is h over 3. So, from this axis. Yung triangle. That's h over 3. Okay. H over 3. Yan yung centroid. Of course, yung area niya is 1/2 base times height. Or you can also... There are other formulas to solve for the area of a triangle. Depende sa given sa triangle, As for semicircular area, ba't walang rectangle dito? Bagay, obvious naman. For semicircular area, since symmetrical naman siya relative to the center line, so obviously, yung center niya from this point ay half ng diameter, which is the radius. So yung y bar natin, yan yung y coordinate ng centroid dito. That is 4r over 3 pi. Ito na derive na. You can, if you discompare kayo, you're not sure, you can use integral calculus to solve for to derive the formula for the centroid of semicircle. So from this axis, the location of the centroid is 4r over 3 pi. Okay, so syempre yung area niya is half ng circle. Okay, so pi r squared over 2. Okay, next, for quarter circle, so x bar natin, the x coordinate, ganyan yung quarter circle, So parehas yung y bar, x bar natin is 4r over 3 pi, 4r over 3 pi yung ating x bar and y bar. Okay? So for parabolic spandrel, ito naman yung formula natin to ito pala. Solve for this location of the centroid, for spandrel. Yan. Okay. What else? For circular sector, ito yung location ng centroid natin for circular sector. Arc, quarter circular arc, arc of a circle. Okay. We are going to focus or concentrate more on the areas, centroids ng plane areas. Okay. Ito. Yung rectangle, ba't di ko nasali dito yung rectangle? For rectangle, very obvious naman. Ay, na-discuss ko na pala kanina. Yung center natin, if this is the base, and this is the height, so yung location ng center natin, that is b over 2, and ito naman, yung location niya, this is h over 2. Ayan. So, simple. Rectangle. Okay? So, i-memorize na lang natin yung formula. If you don't want to memorize, you can derive using integral calculus. Okay? So, you can memorize yung location ng centroids for each of these regular shapes. Alright? So, all right. So that's the introduction of, oh no, what happened? A brief introduction of this chapter, okay, centroids and centers of gravity. So sa next video, we are now going to discuss how to solve for the centroid of composite areas, okay? So see you sa next na video.